Yes. Now let us see the fourth method. Already we have seen three methods: bisection method, regular falsy method, secant method. So next fourth method is iteration method. It is called iteration method. Iteration method. So here also we will find a root. If alpha, these points we have to remember, if alpha is a root of f of x is equal to 0, then we write equation for f of x is equal to 0, which is equivalent to, we write it as f of x is equal to 0, we write it as here in the iterative technique, f of x we write it as which is equivalent to x is equal to phi of x. So you will write x as function in x. This is iterative method technique here. So now if we observe the second point, what is the condition here is, we will observe between which two values the root is. I, the interval containing alpha, because alpha is a root we are taking. If alpha is a root, so there will be an interval definitely because if the root is between 2 and 3, the value or the root will be between 2 and 3. Suppose 2.6701, 2.3242. So that is alpha, the value or the solution for the given function. One root of it is alpha. So there will be an interval I containing alpha. Then, so here the third point what we have to remember is modulus of phi dash x. The condition is modulus of mod of phi dash x should be less than 1 for all x belonging to capital I interval between which two values the root is. So if you find derivative for this, if you substitute any value in the interval I, it should be all the time less than 1. So whether it is minus or plus, we don't bother, we consider only the positive value. So that is the condition. So now we will perform, if all these three conditions are satisfied, then we will perform iterations on x is equal to phi of x for x naught, x1, x2, so on. And when two successive values are same, we will stop the iteration. This is about iteration method. See, if alpha is a root, where is alpha? It is in the interval I. Then from the given function f of x, we will write x is equal to phi of x such that this condition is satisfied. Where, what is that condition? Phi dash x, modulus of phi dash x should be less than 1. So now let us see a problem. Using all the problems in this unit, they will mention the method using iteration method. Find a root of the equation. X cube plus x square minus 1 is equal to 0. Right. So this is the problem. So now here we will take, let f of x is equal to, for all the problems we need to find between which two values the root is. X cube plus x square minus 1. So now see what is f of 0. F of 0 is minus 1 less than 0. F of 1 is 1 plus 1 minus 1. So it is 1 greater than 0. So the root is between 0 and 1. Therefore, the root is between 0 and 1. So this is the interval. The interval I which I am mentioning here. Therefore, I is equal to 0, 1. The interval is 0, 1. So now from the given function, I must be able to write x value. How many ways we can write here? We can write x in 4 ways. 4 ways of writing x is possible here. See, so x cube plus x square is equal to 1. So this implies x into x square plus x is equal to 1. So this implies x is equal to 1 by x plus x square. This is one way. Next, x cube is equal to 1 minus x square implies x is equal to 1 minus x square whole power 1 by 3. This is our phi of x. How many ways we can write? I am telling you. This is also phi of x. We can write in this way. Next, x square is equal to 1 minus x cube. So what is x? It is 1 minus x cube whole power 1 by 2. Even this is also our phi of x. Next, what is the other possibility here? So already we have written 1, 2, 3. So next remaining process is, if I take x into x square, if I take x square as common, I can write 1 plus x. X square into 1 plus x is equal to 1. So what is our x here? X is equal to 1 by root of 1 plus x. 1 by root of 1 plus x, or we can write it as 1 plus x whole power minus half. So beyond this there are no possibilities. So I can write, using the given function here, I can write x is equal to, so this is the point which we are now verifying. X is equal to, I can write it in 4 ways. Now I will take this as first case, this is second case, third case, and this is fourth case. So now in each case I have to find phi dash x. So in the first case, let us see what is phi of x. Phi dash x. Phi dash x in the first case is minus 1 plus 2x by x plus x square whole square. Derivative, 1 by x derivative is minus 1 by x square, and derivative for the term inside the bracket is 1 plus 2x. So now this is for the first case. For the second case, see what is phi dash x for this. Phi dash x is equal to 1 by 3 into 1 minus x square whole power minus 2 by 3. 1 by 3 minus 1 is minus 2 by 3 into derivative of minus x square is minus 2x. This is phi dash x for the second function. For the third possibility, see what is phi dash x. Phi dash x is equal to third one, 1 by 2 into 1 minus x cube, 1 by 2 minus 1 is minus half into derivative of my x cube is minus 3x square. This is another phi dash x. So for the fourth one, for the fourth possible case, this is the one. So what is phi dash x? Phi dash x is equal to minus half into 1 plus x whole power minus half minus 1 is minus 3 by 2. Minus 3 by 2 into derivative of x is 1. So now these are the 4 possible cases. So for all these possible cases, now we have to verify in the interval. What is the interval? 0, 1. The value of phi dash x, for whatever value we take between 0 and 1, it should be less than 1. So now you can feed these functions in Calc and you can check. If I substitute here instead of x 0, what happens? 1 by 0, it is infinity. It is not less than 1. So if I substitute x as 1, 3 by 1 plus 1. So here for the 0 value we get here infinity. So if you feed these functions in the Calc and if you verify only this function, so which one? The fourth one, 1 by root of 1 plus x. So, only this value will be between 0 and 1. All other values, if you verify in Cal C, for the values between 0 and 1, they will be greater than 1. Greater than 1. So, this one, only this function satisfies. When x is 0, 1 by 2, 1 power minus 3 by 2. So, it is 0.5. Next, when x is equal to 1, it is 2, 2 by 2. So, it is minus 1. So, it is less than or equal to 1. So, here what is our, for this, when, here we have to write. We verify all these values in Cal C. Using calculator, we will verify. After verifying, what is that we get here? So, we get that for some value between 0 and 1, all these values, modulus of phi dash x is not less than 1. For all, if you observe here, for all. If even it fails for a single value also, the function we can't take it as phi of x. So, what is that which suits for us here is x is equal to 1 by 1 plus x. So, for x is equal to phi of x is equal to 1 by root of 1 plus x, modulus of phi dash x is less than 1 for all x belonging to 0, 1. Therefore, we will perform the iterations. Initial approximation, we need initial approximation. X naught is equal to, between which two values the root is? Between 0 and 1. So, 0 plus 1 by 2, it is 0.5. So, now we will perform all iterations to this function. So, performing the iterations, what is that we get? X1 is equal to phi of x naught, phi at x naught. So, this is equal to 1 by root of 1 plus 0.5. X naught is 0.5. So, if you evaluate that, so we get here 0.8165. 8165. Similarly, now x2 is phi of x1. So, if you substitute this value 1 by root of 1 plus 0.8165. So, its value is x2 is 0.74196. x3 is phi of x2. It comes to be 0.7577. 0.7577. Next again, x4 is phi of x3. Its value will be 0.7543. 7543. Next, x5 is equal to phi of x4. All these we will substitute in this function, all x values. So, this is x5 is 0.755. Next, x6 is phi of x5. So, if you evaluate, x6 is 0.75485. 75485. So, it is almost equal to 5. 48 means. X6, x7 is phi of x6. So, what is its value? If we substitute here 1 by root of 1 plus 0.75485, it is 0.75488. So, we can stop here. After decimal, 4 digits are same. Therefore, the root is 0.75488. So, that is how we have to use iteration method. Choosing phi of x is the important point here. So, if you verify for all these using calculator, we are taking values between 0 and 1, say 0.2, 0.6, 0.8, 0.9, even 1. So, if you substitute between these two values, all the values if you substitute in these phi dash x, they should be less than 1. So, we take only positive value. The function which satisfies this condition, modulus of phi dash x is less than 1, will be taken for iterations. That is iteration method.